Today is going to be 70-2. We're going to continue describing a rational function, and more importantly, we're going to look at horizontal asymptotes and oblique/slant asymptotes. So we're going to find those horizontal asymptotes of a rational function, and we're going to find the slant or oblique asymptotes of a rational function. Now remember yesterday, we said that with this example graph, right, if I were to graph it, we said that this graph has like this leveling off along here, right? As it goes down here, it levels off about there. As it goes up forever here, kind of like levels off there. And what I said is that that leveling off is our horizontal asymptote. So how do we actually find those horizontal asymptotes? Well, we're going to use these rules to help us be able to determine what the horizontal asymptotes are. So the definition says let n be the degree of the numerator and m be the degree of the denominator. Remember, degree means the highest exponent. Okay, the degree means the highest exponent of your polynomial. So we're taking the highest exponent of the numerator and the highest exponent of the denominator. Now we're going to compare them. In this first scenario, if the degree in the denominator is larger, it's automatically y equals 0. If the degree in the numerator equals the degree in the denominator, it's a ratio of the leading coefficients. If the degree on the numerator is larger, there is no horizontal asymptote. It's going to be an oblique asymptote, and you have to divide the polynomials to find it. So let's look at a few examples here. In this first example, my n is 2, my m is 3. So now I need to compare them and see which scenario it lies under. Well, m is larger than 2, so m is larger than 2, so it's automatically going to be y equals 0. On example number 2, my n is greater than my m, right? 3 is bigger than 2, and so therefore there is no horizontal asymptote. I have an oblique asymptote. Here, my degree is 2, my degree is 2, they equal each other. So therefore it's a ratio of the coefficients, so a ratio 2 over 1. And so it's going to be y equals 2. And so that's how we're going to find our horizontal asymptotes. You have to make sure that you use this chart to be able to determine that. So now let's find our oblique or slant asymptotes. So the one piece of information that was not talked about was case 3. Now when case 3 does occur, there isn't a horizontal asymptote. Remember, it's going to be that oblique asymptote. Now to find the oblique asymptote, you divide the polynomials. Then the quotient, excluding the remainder, is the equation that represents the asymptote. So say that again. To find the oblique asymptote, you divide the polynomials. The quotient, excluding the remainder, is the equation that represents the asymptote. So in this case, my n is 3, my m is 2, my n is greater than my m. So because of that, I know it's going to be an oblique asymptote or a slant asymptote. And so to be able to find that, you have to divide the polynomials. So to divide them, x squared plus 1. Now you have to use long division because it's not a degree of 1. So it's going to be x cubed plus 2x squared. I don't have an x, and then I have my 2 here. So now dividing, x squared goes into x cubed, x times. Distributing through, you get x cubed and x. Now remember, we have to subtract. So x cubed minus x cubed is 0. 0 minus x is negative x. Bring down the 2x squared and the plus 2. So x squared goes into 2x squared 2 times. Multiply that through, you get 2x squared and 2. Subtract. So you're going to get 0 and 0, and then bring down the negative x. And so this right here, this is going to be my oblique asymptote. Now remember, we do have this remainder of negative x, but we ignore it. And so my slant or oblique asymptote is going to be y equals x plus 2. My slant asymptote. Now finding the oblique asymptote here, if I were to divide these, now because this is in the form of a linear factor, like x plus 1 in this instance, I can use synthetic division. So using synthetic division, I'd put the negative 1 here. Now counting down, I have 2x cubed. I don't have an x squared. my 3x, and then I need to put a 0 for my constant. And so now I need to follow the pattern, bring it down, multiply, add, multiply, add, multiply, add. Now counting backwards, this is my remainder, my constant, my x, and my x squared. So then that means that I'm going to have 2x squared minus 2x plus 5. That's going to be my oblique asymptote. It's going to be the equation y equals. Now you remember, we ignore the remainder when we are trying to find our oblique asymptote. Now this is something that it's examined the reason why later, but if you're wondering why don't we include the remainder, it's kind of like a brief topic that's analyzed a little bit once you understand limits a little bit more. So that's almost like a to be continued once you take calculus. Now if you have any other questions, please leave them in the comments.